Other simultaneous equation or simultaneous equations. We do know how to solve. Up till now, we have learned how to solve equation of one variable. So it's of the type y, for example, let's say y 2x plus 1. And from here, we ask the following question. Can we find values of x and y, and how many, that are solutions of this equation, which I will abbreviate in that way. How many are those? Okay, immediately we can say, let's take x equals 1, then if y is equal to 2 times 1 plus 1 equals 3, the pair xy, which is 1, 3, is a solution. Is this the only one solution? We are asking ourselves. And in order to answer this question, we should think a little bit, how else can we interpret such type of equation? Firstly, what is this equation? X and y are two unknowns, and the expression y equals 2x plus 1 is a linear expression. What does it mean, linear expression? It means that x and y are of degree at most 1. It could be 0. And now our teacher is asking how many solutions we can, if we take another value of x, we could find another value of y, again, which fulfills or is a solution of this equation. And here comes the following thought, I would say. In geometry, y equals 2x plus 1 is an equation of a line. Pay attention to linear and line. What does this mean? Let's draw very briefly and approximately the equation of this line. When x is 0, we do have y to be 1, and when x is equal to negative 1/2, y is 0. So this is negative 1, negative 1/2. So those 2 points are points on the line y equals 2x plus 1. And we know that 2 points identify uniquely a line that passes through them. Take an arbitrary point on this line. Let's say the point P. It has x coordinate x and y coordinate y. And these coordinates of the point on the line are related by knowing that y is equal to 2x plus 1. Hence, any point of the line, any point of this line is a solution of our equation. In other words, this equation, we usually say that this equation y equals 2x plus 1 has infinitely many solutions.
Sorry, I just have to say that it's slightly out of frame. But yeah, perfect.
Yeah,
Thank you.
thank you. That's how it works in reality as well. Yeah, because if I move it, it becomes too small.
Yeah,
And
no worries.
yeah, infinitely many solutions. That is nice. Then we ask another question. Can such linear equation has no solution? And the answer to this is no. It always has. Always has. In fact, as we said, infinitely many solutions. And this equation in mathematics, the equation of that type, which can be written in the general way, ay plus bx plus c equals 0, where a, b, c are given constants. And y and b and x are unknowns, sometimes quite often called variables, has infinitely many solutions. Of course, having infinitely many money is a good thing, but in mathematics, quite often we would like to find unique or only one solution. That is why, from this little analysis, we can conclude that one equation with two variables cannot have unique solution. Hence, in order to be able to be more precise in our goal to finding several things or several conditions because this equation can be looked at as a condition about x and y, we can look at the so-called systems of equations. And in particular, we might consider the following. So let's say a system of two linear equations in two unknowns. We can write a general, how to say, expression for such a system, but I would prefer to have something that is a little bit more particular. Let's have another such system. That means we should have two linear equations and two unknowns. Let's call them x and y again. Let's consider one such system. We might expect that as we saw, that if we have only one linear equation and two unknowns, then we cannot have unique solution. And we might jump into a conclusion that if we have two unknowns and two linear equations, then we might almost always find unique solution. But unfortunately, as usually in life, things like this happen. This is not always true. Let's look at the following system. 2y plus x equals 20 and 2y plus x equals 10. Can we find, is there a unique solution? To this equation? Can we have x and y's such that 2y plus x is 20, but in the same time 2y plus x is equal to 10? Obviously not. So this is a system of two linear equations which has no solution. Okay, maybe this is some, how to say, two-bad system. Let's look at another one and see if another one can have unique or more solutions. Let's look at 2y plus x equals 10 and 4y plus 2x equals 20. In this case, we notice that the second equation can be written as 2 times 2y plus x equals 2 times 10. And we have a factor 2 to the left and a factor 2 to the right, and we can cancel, and as a result, it turns out that the second equation, in fact, is equal to the first one. Hence, if we consider this again a little bit strange system, it has infinitely many solutions. So we might think, well, are there at all systems of linear equations that do have unique solution. In order to have a little bit more visual approach and understanding, I would do the following. How can we interpret a system of linear equation, or how we can visualize them? Equations, I will abbreviate a little bit, and how can we investigate the number of solutions? Number of solutions is always very important one. It will depend if we have only one house or infinitely many. So we said that if we have a single equation, 2y plus x, let's say equals 10, then its geometric interpretation is a straight line. If we have two, say 2x plus y equals 10, and x plus 3y equals 7, then in fact we have one line and another line. So we do have two lines. If we do have two lines, things become a little bit easier. Why? Because the question of existence of solutions of such a system and how many of them is being reduced to the question what possible interrelation two lines in a plane have. And this is much easier question to be asked. Why? Because if we have two lines can intersect, they can coincide, and the third possibility is they can be parallel. Let's draw some picture which will make things even easier for us. So let us draw a coordinate system, again approximately, and I will draw approximate lines. So let's have one line, L1, and another line which intersected, L2. As we see, they intersect in only one point, hence we have unique solution of the corresponding system of two linear equations with two unknowns. Then the other possibility which is a little bit difficult to be drawn, is if we have one line, L1, and another line which coincides with it, L2. In this case, we have infinitely many solutions to the corresponding system. So, to the corresponding system of linear equations. And in a similar way, the third possibility is when our two lines, so this is x, o, y, x, o, y, the coordinate system x, o, y, with origin O, we have one line and another one that is parallel to this. This is line L2 and this is line L1. So no solutions. Of course, if we have a system of linear equations, two linear equations with two variables, we don't always should resolve to drawing the corresponding line and finding the point of intersections, because this point of intersection is clear from the picture, but in order to solve the equation, we should know its coordinates x0 and y0, respectively. And that is why we use some algebraic methods of solution. Which can be methods of solutions, which can be roughly classified in the following way: by substitution. We express one variable from one of the equation and substitute it into the other. In that way, we obtain one equation with one variable which can be solved. Let's see how this works for one of the systems that I mentioned previously. So we consider the following example. 2x plus y equals 10 and x plus 3y equals 7. It doesn't really matter from which equation we express the one. I would choose, just for the sake of variety, the second one. We express x as 7 minus 3y. And After we express it, we replace x in the first equation with this expression. Let's do it. As a result, we get the following. 2, instead of x, we write 7 minus 3y plus y equals 10. We open the brackets, or we expand the brackets, expand brackets, and we get 14 minus 6y plus y equals 10. Minus 6y plus y will give us minus 5y. So from this equation, we obtain the equation 14 minus 5y equals 10. We know that if we add 1 in the same term, adding same term to both sides of an equation doesn't change the equation. I would add 5y. And as a result, I would get 14 minus 5y plus 5y equals 10 plus 5y. At the left hand of this equation, left-hand side, we do have negative 5y and 5y. Those are similar terms. After simplification, so simplify, we get 14 equals 10 plus 5y. Now we continue to do the same operation, adding or subtracting, the same term from both sides. And because we want to make y the subject, we should subtract from both sides 5y. And we go to the next page and we obtain 10. I'm deeply sorry. You should have told me that this is not correct. We want to make 5y the subject. If we subtract 5y, we will make 10 the subject. But if we subtract 10, we would make 5 the subject. And in that way, we obtain 14 minus 10 is equal to 10 minus 10 plus 5y, or written in another way, we obtain 5y equals, so those two terms would cancel, and we get respectively 14 minus 10, so 5y is equal to 4. Hence, we have found the value of y. It is 4/5. Now we have to find what value of x corresponds to this value of y. So in order to do that, we go back to the point where we express x through y. So we did, and we found that x is equal to 7 minus 3y. So now we should replace y with the value we obtained, and in that way we get x is equal to 7 minus 3 times 4 fifths, or 7 minus 12 fifths. In order to find the final value of x, we have to represent both of those terms as fractions with the same denominator. We can always think about an integer, which is 7, as having denominator 1. Hence, in order to represent both of them with the denominator 5, we have to multiply and divide the first term by 5, and then we just complete what we have as a second term in this expression. Fractions with same denominator are being subtracted by the following way. We have as a result fraction with the same denominator, and on the top we subtract the numerators. 7 times 5 is 35 minus 12, so we get 23 over 5. Hence, the final solution to our system will be x equals 23 fifths and y equals 2 4 fifths. This will be our final solution. And this is algebraic solution of the system. Through substitution, we can have other ways of solving such system, namely, for example, by correspondingly let us say eliminating one of the unknowns from both equations. We can give such example so this is, let's say, method 2. We can solve such example at the end, but before that, I would like to emphasize a little bit on some more complicated system of equations. For example, what would happen in a system and how we can act of two equations in two unknowns when one of the equation contains one or both variables in degree 2. Of course, we do have some general way of algebraically solving it, but what I would like to emphasize is to build an intuition what would be the geometrical analogous or interpretation of such type of system of equations. As I said, not necessarily linear system of equations. For example, let's look at such system of equation. Let's have y equals x plus 3. This is a linear equation or equation of a line. Then let us look at the equation x squared plus y squared equals 16. Such system you can learn and you can have to solve after a little bit more geometry. From geometry, let us look what is the geometrical interpretation of the second equation. And from geometry, we know that this is an equation of a circle with center, the origin, and radius 4. Then the geometrical interpretation of that system will be the following. We take, of course, one coordinate system. We approximately, firstly, let us draw the circle 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And let us have this circle centered at the origin with radius 4. And let us look at the line. So this is the circle with equation x squared plus y squared equals 16. And let us look how the line y equals x plus 3 will look. When x is equal to 0, because we know that a line is completely determined when we have 2 points through which it passes, we put x equals 0 and we get y equals 3, and then we put x equals negative 3 and we get y equals 0. Hence, this line will passes through the points with coordinates 0, 3 and negative 3, 0. Negative 3, 0 is here. 0, 3 is here. And if we draw this line, we notice and we see, now I would need some purple, that it intersects the circle in 2 points. Hence, from the interpretation, geometrical, we see that this system has 2 solutions. In other words, 2 pairs of xy that satisfy. Without going in much details and also without writing a specific equation, just to get the flavor of different type of systems and solutions, let's look at some other cases that can happen. So again, let's have some circle. In fact, it is not important that it is at the center is at the origin. So we have certain circle and the line. Always, if the line intersects the circle, the corresponding system will have 2 solutions. What other possibilities do we have? Let us say, and let us take formally, I say formally because I don't draw exact drawing, but same circle. And what kind of line we could have? We could have a tangent line to this circle. Then the corresponding system will have, 1 second, not to, the system has 1 solution. And what would be the case when no solution exists? It will be the case when the line does not intersect the circle. No solution. All these are possibilities that we can explore even without solving a specific system. So we just know what possible solutions can we have to such system. No solution, 1 solution, and 2 solutions. It cannot have, that we should emphasize, such system cannot have infinitely many solutions. Many solutions. Well, I say that, but how I will argue? Let us contrary. So, contrary. Suppose such system has 3 points of solution. So it is a little bit difficult to draw such case because this case is not possible, but I will draw just the circle, and then we shall argue what can happen. So let us have 3 points on this circle that are, so let those 3 green points are solutions, are 3 solutions of our system. And let us denote them by P1, point 1, point 2, point 3. We know that through 2 points passes only one line. So let L1 be the point that passes through P1 and P2. Okay, let me see, where is my purple? L1, P1, P2. So this is the line. And let L2 be the line passing through P2 and P3. So we get this. But our system, this is a contradiction. Why? Because we have 2 lines, hence 2 linear equations, and 1 circle, hence an equation of second degree with respect to x and y. This is not our system. So if we suppose that we have at least 3 solutions, we get a contradiction. Without going into much details, we can similarly draw cases of similar systems. So let's say we do have, I would say, y equals x plus 3 again, and y equals x squared plus 2. As we already commented, this is equation of a line. And from algebra and geometry, we know that this is equation of a parabola with vertex 0, 2. So let's draw them and see what happens. So the line we have already did it. This is the point 0, 3, and this is the point -3, 0. And when x is 0, the parabola has a vertex 2, and then it goes like this. How many times the line and the parabola intersect? Twice. Hence, this specific equation has 2 solutions. this specific system. This system has two solutions. And let us just draw what else can we have. Just for the sake of drawing, let's have the same parabola, and we can have a tangent line, hence a system with unique solution. And similar situation, not similar, but another situation would be if, again, let's take this arbitrary parabola and a line that is parallel to x-axis. So in that case, we have no solutions. And this is just to give you some insight how we can figure out and what does it mean to find the number of solutions of two systems, one of the system of equations, one of which is, so firstly we consider a linear system, then we consider a system in which one of the equation is of second degree, special equation, but we can have also systems in which both equations are of second degree. Say x squared plus y squared equals 14, and again y equals x squared plus 2. We saw that this is a circle and this is a parabola. And let us see, just by drawing, without finding them, how many solutions do we have. So the parabola will be, let's say this is 2, like that, and the circle center and radius 4. So we have two intersection points, hence two solutions. But what other possibilities do we have? So we can have some parabola and a circle lying either outside it or inside it. Hence, no solutions. Also, can we have the following situation? Again, we do have some parabola, and I would draw one very menacing circle, like that. So in that case, we have 4 intersection points, hence 4 solutions. There is one more possibility. And think and draw for the next time.